Good evening, everyone. This is Veer Maheshwar Charitable Trust Latur MS India organizing this international webinar series. In this series, speakers are invited from India and abroad, and speakers are delivering their talks as per their expertise. Every day, this series is running from last 5 years, and we are very happy to invite speakers from India and abroad. On 13th August today, we have invited Shiva Prasad Munukuntla sir, who is assistant professor at University from Bengaluru. So the topic is predictive maintenance for operational excellence. This topic is new for us. I request speaker, we are not from technical side. You can make this topic simple as per your interest. Thank you, sir. I welcome you again from my participants and from our organizers. And I request you, you can start your speech now. Thank you.
Okay, sir. Thank you, sir. Thank you for the introduction. Hello, everyone. Good evening. Myself, Shiva Prasad. Let me present my topic. Sir, it is visible, right?
Yes, sir.
Yes, sir. So, myself, Shiva Prasad Munukuntla from Jain University, Bengaluru. So, the topic is predictive maintenance for operational excellence. What this means in simple terms, I will explain. In day-to-day life, we are building many products and like anything we are building now. So my focus is to give you ideas what technologies we have and where our current technology is in achieving this. So if we have good predictive tool, we can maintain downtime, reduce downtime by 30 to 50%, and we can reduce cost by 10 to 40%. So we will see what are briefly we will see what computer science is trying to solve in this field. And then I will give examples where it is applied and how it is helping. So this is basic history. In 1920s, it was reactive. Like when it got failed, only we intervene it and we fix it. You can take any car or turbines, anything. But after that, time schedule. Even now, we will give our bikes and everything for service, like at scheduled time. So it will reduce our maintenance cost. From 1950, it is followed. From 2000, it is condition based. Like we are applying some intelligent models on the machines, and we are predicting when they are going to fail. So before fail only we are fixing. Like if some spark plug is going in a scooter, the electronic unit will identify it and it will show an alarm. Your engine oil is wear out or grease is less. So we will see how condition based helping. And after 2020, after rise of LLMs, how they are helping us to identify and do this task very fast. We will see that. So conditional based management means based on conditions. Like if you take a car, how much vibrations it is, that how much temperature, pressure. Based on those, we will analyze. And not by calendar. Like earlier we used to do, if vehicle is good also, even if we use it or don't use it, after 4 5 months we used to change. But the things got changed now with a lot of sensors and all those things. Before anything is going to happen, the sensor will intimate us. So we can take to maintenance after certain inputs are given. So to do this, first we need to acquire the data, and we need to clean the data and extract the data, and we need to detect. For a detection part, we use our models. Acquiring data is simply collecting data from the model sensors. Whatever sensor is there, it will daily collect the data, and AI model will be observing those data. 1, 2, 3 is a one-time setup. From wait 4, we will have intelligent models. For different problems, we'll use different models. We will see on the examples. So the main thing what we are trying to do in this, if you observe what is anomaly detection is, daily you are using your scooty, you are not facing any issue, but one day you observe that engine is getting too much heat, so you ignored it. After some few weeks again it came. So anomaly is the thing which won't follow a pattern. So we will try to identify those patterns using machine learning models. So anomaly detection is this thing. Whichever falls under normal pattern, we will try to identify, or whichever tending towards abnormal pattern through the time. So we will try to find out those patterns using machine learning models. There are two types of anomalies: point anomaly, like it's single observation we will say, and continuous means by like every day we will be observing it. So what algorithms and techniques we use, briefly I am explaining them. This is basic. Like generally, if you observe any, if you visit any company, also any hardware company, you will be notice that they will have some charts always running on the computer. They will be monitoring the charts. What is in the chart means, for each interval, maybe 5 minutes, 10 minutes, they will be noting the temperature or pressure, and the chart will be forming. Like normally if you see ECG also, heartbeat also same like that in hospitals. Each 5 seconds it will take our heartbeat and print on the chart. So we will see these patterns. We will set some thresholds. Like if heartbeat goes greater than 100, the patient is getting tension, so we need to give the medicines to reduce the heartbeat. So earlier, we 100 years ago, like even now, for some models we are using these charts. They will have some threshold, upper threshold, lower threshold. If it is going below lower threshold, also it is a problem. Upper threshold also it is a problem. So in normal range, if it is there, it is okay. That is a basic way of detecting anything is going wrong in a system or any machine. From then, 2000, we got world-class SVM isolation forest. Generally, what we these models do means, daily they collect the patterns and they draw a 2D chart. After that, it will try to draw a circle. One-class SVM try to draw a circle. If any pattern, any point is going beyond the normal pattern, we can identify it as anomaly and we can fix it. So isolation forest also, it will try to construct a tree. Both are almost same. And after that, we got some intelligent models. These are deep learning models. What self-organization maps try to do is take all data and map those data from higher dimension to lower dimension. So whichever all points falling near this blue, those are normal. Whichever are very light blue, they are abnormal. So we try to identify those and apply. All these are applied once. Like these are not continuous models. Continuous models, what we are applying, we'll see. Even SVDD, DPSRD, these are unsupervised. These are the same like them. So these autoencoders and LLMs are, these two are continuous models. Like these two models, we deploy them on the machine, and they are continuously observing the machine 24/7, because humans cannot observe 24/7. So they will be on the system, and whenever something goes wrong, they will alert to the respective maintenance guy. Then he will take care if any anomaly is there. Even LLMs we are applying on them, and we are seeing how anomaly detection they are helping. Like in everywhere LLMs are there now. So generative AI, we are using those in predictive maintenance also. It will help the maintenance to understand, instead of reading a lot of errors. It will summarize what is happening, which areas you need to go and quickly fix in gas station or anywhere. So like that, LLMs are helping us. So here are few industry applications I noticed. First is wind turbines. You may be aware of these wind turbines in India. We are moving towards green energy more. So everywhere we are seeing wind turbines are installed by government or private companies. So in this, what happens means, At this top, this is very height. You may be aware of wind turbines. Very height here, the engine, gearbox, generator, all will be there. Engine won't be there. Generator and gearbox will be there. Here at the front, motor will be there. When wind comes, this will rotate, and after that, with the rotation, the electricity is generating. But the thing is, every day maintenance guy cannot go up and check like all are working correct or not. We need to apply any grease, any oil or grease to the engine, or we need to replace any motors. He cannot see that. So what they do means they install sensors everywhere at the motor, at the generator, at the gearbox, and they install the models I explained earlier. So if anything goes wrong, it will inform them before 1 2 weeks also. So if it got breakdown, what happens means one, it will burn or the fans may broke. It will destroy entire wind turbine. Instead of that, if we have our predictive models, before it got breakdown, we will know that it is going to fail. So we will switch it off, and we will repair it. So it will save our wind turbine. So this is real world example how we are using AI and machine learning models to reduce the cost of maintenance and products. So this is one more bearing CNC. In every machine, wherever we have, there is friction. If friction is there after few years or sometime without maintenance, they will break. So with anomaly detection and predictive maintenance, we can identify those. And one more is jet engines also. In this, the mode like everything is taken by models only from autopilot. Like the system will be there on the aeroplane. It will check all parameters. If you see any screen, it will be always printing like engine is working well. In movies also you may have seen if anything goes wrong, system will alert right engine fail, left engine fail, some body hit in the eight turbines, it will say bodies hit in the eight turbines. So sensors are everywhere, they're observing. If anything is going to happen before only they are informing us so that if engine is about to fail, we will try to see land early only. Like that, it is helping us. It is mainly used in oil and pump oil also because pressure, these things are very important to them. Actually, in software, this is a big industry. Like there are many companies in India, like Infosys, Wipro also, they take care projects of Middle East, and they maintain the softwares for this. They daily observe that they daily observe what is going on with machines. They are trying to implement these models in the company. In my old company also, we were developing for ticket machines. Oil was not our part. For the ticket vending, we developed. When wind turbines also, we developed models. So those are the examples. So what are the challenges, best practices, and future? We'll see. So general challenge is this data. Like different sensors will have different form of data. So collecting them in a simple single format is a challenging task. Once it is established, it is very easy from them. So this data different format and sensors different, and we need to label them, and we need to identify. Sometimes 24 hours we don't know data is correct or wrong, so we need to clean the data. And also the gap, we need to train people to check that collecting sensors are working or not every day, so that we need to ensure for good predictive maintenance. So for successful, we need to have wherever we want to implement this, we need to talk with the customers, and we need to install sensors wherever we need them. And first on before collecting data only, we need to ensure that data is in good quality. And research anyway it is going on for it is open source. So first two things we need to take care. From if model is established, from then we can simply monitor it. So this is the future. Generative AI, it is going a lot to come into this picture because till now we have only machine learning models. Deep learning models are not there in anomaly detection because the main issue is for anomaly detection, the data is unlabeled. It is unsupervised also. So it is a big challenge for machine learning models to identify those patterns, but it is very easy for the generative AI to identify unlabeled data or patterns in data. Yes, this is the summary. Thank you. Any questions you can ask me.
Thank you, sir,
Okay, thank you,
for
sir.
your
Okay, so if you any
technical
doubts, you can
and
ask. Okay,
yes,
sir. Thank you, sir.
and thankful to you invitation.
Okay, thank you, sir.
Now I request our participants they can discuss with our speaker. The feedback link is available in the chat box. All are requested to fill the feedback link. Thank you, sir. No one is asking any question. I am very
Okay.
thankful to you
Yes, sir.
and
Thank
thankful to our Somshekar sir,
Yes,
Somshekar
sir.
sir,
Yes, sir.
for giving me this, yeah, for giving me you this
Yes.
opportunity and introducing you to this webinar. Thank you, sir. Thank you.
Thank you, sir. Thank you very much.
Participants are requested to fill the feedback link given in the chat box.